this issue of ABC's Wide World of Flying, you'll fly a LearJet with Captain Barry Schiff in the second part of a two-part series. You'll check out the Cessna Skylanes from first to last, as Bill Cox shows you why these airplanes are so prized by pilots today. Phil Boyer will show you the Lasertrak, an exciting new piece of technology that eliminates the tedious updating of the charts, and his personal selection for the perfect intercom. Rob Machado focuses on NDB instrument approaches and will give you several tips for making this difficult approach a bit easier. You'll go behind the scenes at the RENO Air races with Corky Furnoff and the entire crew of Tsunami, our first all-new unlimited racer since World War II. In our bonus buyer's guide at the end of this tape, North Star Avionics shows you how the French connection enjoys the benefits of Loran Sea navigation. John King discusses common traffic advisory frequencies, and Martha King shows you how to plan your descents. ALPA shows vendors how to better utilize their services. All this and more in this issue of ABC's Wide World of Flying.
Welcome to the third video edition of ABC's Wide World of Flying. As with our previous video issues, we've tried to select topics of interest to those in general aviation. Take this video, for example, which spans unlimited racing at Reno 87 all the way through learning to pilot a LearJet. Our philosophy is to present a positive and upbeat quarterly video program for those who love to fly. Now, while many complain about the state of the general aviation industry, our editorial attitude is not to cry about the lack of new aircraft production. If that's the way the market is, so be it. Lots of innovative and exciting things are happening in aircraft modifications, refurbishing, and refinishing. Not to mention the home-built market, which continues to provide new designs, materials, and techniques. The computer age is bringing unusual technology to all facets of aviation, and many new avionics and flight control systems are finding their way into our airplanes. Yes, regulation is increasing, and Mode C transponders, special use airspace, and other restrictive measures will continue to be imposed on the general aviation pilot and plane owner, especially if he or she flies in our busy terminal areas. These changes, however, are not being brought about by diminishing, but rather increasing use of the airspace system. Those of us who fly enjoy a reward that few other experiences can bring. We at ABC's Wide World of Flying will continue to try to bring you those exhilarating experiences in an informative and yet optimistic manner. To prove my point, let's get underway with Volume 1, Number 3 of our Aviation Video Magazine.
Well, I'd like to welcome you to Part 2 in this series of flying a LearJet Model 35A. I know it's been a long time, 3 months, since we pre-flighted the airplane, but I assure you it's ready to go. Obviously, I can't take you on this flight by myself for the simple reason that I'm a pretty inexperienced Lear pilot. I don't have a type rating. So accompanying me on this flight is LearJet Corporation Captain David Sullivan, who's seated to my right. Dave, why don't you say hello? Hello. You saw his hand anyway. Well, without much further ado, what we'd like to do is start engines and get underway. Before we start engines, however, I'd like to tell you a little bit about what's going to happen, because starting an engine on a LearJet happens pretty fast. What we're going to do is engage the starter for the left engine, and the first thing we're going to see is the turbine RPM begin to increase. And once it reaches 10% RPM, then I'm going to reach over to the thrust levers and raise the thrust lever to the detent, and that will allow fuel to flow to the engine and turn on the ignition at the same time. We'll also see the turbine temperature rise. We'll see the fan RPM increase. We'll see some fuel flow, of course, some oil pressure. And it all happens pretty quick. If you're ready, so am I. Right now, we'll engage the starter for the left engine. There goes the turbine RPM, 10. We add fuel. Turbine temperature coming up, fan speed increasing. We have a little bit of fuel flow. The oil pressure is coming up. The engine will stabilize in a few seconds. We want to make sure during the start that the temperature doesn't get too hot. If it does, we have to abort the start. Okay, the engine is stabilized now. We'll turn on the generator for that engine. And it stabilizes, notice, at about 60% turbine speed is idle, about 475 degrees turbine temperature, and the fan speed is approximately 30%. We have about 250 pounds of fuel flow roughly. Oil pressure is good. We'll repeat the process now with the right engine. We'll engage the starter. Wait for 10%. Open the fuel valve, add ignition. Watch the temperature, make sure it doesn't get too hot. Oil pressure is good. Turbine speed stabilized at about 60%. And that's all there is to it. All you do is engage the starter and wait. Everything else is pretty automatic. I should add that at about 50% RPM roughly, the starter motor cuts out. And once the engine has started, the ignition shuts off because, as indicated in session 1, once you start a jet engine and the fire is raging, you don't need to keep an ignition source. It keeps going by itself. One nice thing about the LearJet is that it has so much residual thrust that you don't have to add any power to begin the taxi. All you have to do is release the brakes. Here we go. One thing that takes a little getting used to about a LearJet is the fact that it has this electrically operated nose wheel steering. It's very, very sensitive, and it takes a little bit of getting used to. Another nice thing about the LearJet, of course, or any jet airplane, is that it will not be a mag check. You don't have to check much of anything except to make sure that the systems are operating normally. There's no engine run-up, of course. Point worth repeating is that these engines produce so much power when they're idling that if you allow the airplane to continue to accelerate on a long, flat, straight surface, you'll get going too fast. Every once in a while, you have to add a little brake to prevent it from getting away from itself. We're going to pull off to the side there so we don't block any other traffic that is released before we are. Now, while we're waiting for our departure release, this might be an interesting time to dispel kind of a myth. As you can see by the fuel flow indicators, each engine is burning about 200 pounds per hour, or a total of 400 pounds per hour. That works out to be approximately 50 gallons per hour we're burning while sitting on the ground. There used to be an old wives' tale that insisted that if you sat on the ground very long in a jet airplane, you'd burn up all the fuel and you wouldn't have any left to go anywhere. Well, that might have been true with the older generation turbine engines, but it's true with the newer engines. Runway items are complete. Thank you. We have airspeed alive. P1. Rotate. Right turn 210. Up to 10. Isn't bad, 3,500 feet a minute, 250 knots indicated. The nice thing about reaching 10 is you can accelerate above 250. Boy, look at that acceleration. Flight level 200. As we leave 26,000 feet for a assigned altitude of 37,000 feet, the indicated airspeed is still 250. The Mach speed is 0.62 Mach, and the true airspeed has increased to 380 knots. One thing that's interesting is notice the fuel burn during the climb at 27,000 feet. Each engine is burning 900 pounds per hour, or a total of 1,800 pounds per hour. As we go higher and higher in the climb, you'll notice for the same power setting, the fuel flow will decrease. This is because the engines develop less and less power as we climb, just like naturally aspirated piston engines. Both the leading edge of the wing and the leading edge of the stabilizer are indicating in the icing range. Of course, we're flying in clear air right now, so there's nothing for us to do about it. With these indications, if we were flying through cloud, we turn on the wing anti-ice system. You'll notice now, as we approach 36,000 feet, the engines are only burning almost 800 pounds per hour each, whereas earlier they were burning 900 pounds per hour each. So as the engines lose power, the fuel computers sense all of this, along with the outside air temperature and pressure, and actually reduce the fuel flow to the engine. So we're now leveling off at 37,000 feet. We had been climbing at a Mach airspeed of 0.7. Now we're going to leave climb power on, allow the airplane to accelerate to Mach 0.77, which is the normal cruise speed, about 77% of the speed of sound. And at that point, we'll reduce the power using the fuel flow gauges, reducing to approximately 600 pounds per hour per engine. Also, another item that indicates the fuel efficiency of this airplane, it took us 16 minutes to climb up to 37,000 feet, and we're pretty heavily loaded today. The total fuel burn was only 600 pounds. Okay, we've reached Mach 0.77. We'll now reduce the fuel flow to approximately 600 pounds per hour. That's all she wrote. You don't have to worry about cowl flaps, mixture settings, changing propeller pitch. Operating a jet airplane in many respects is much simpler than operating a conventional twin, for example. The only thing you have to worry about in a jet airplane is staying ahead of it. It's so fast. Things happen so quickly that you have to think way ahead. If you don't, it'll overwhelm you. You know, this airplane has everything. One thing it doesn't have is a chart holder. Don't you love the way Dave has created a little fold in his pants? $3.5 million airplane and no chart holder. Be interesting to take a look at exactly what we're doing at 37,000 feet. The indicated airspeed is 248 knots. Doesn't sound like much, but when that converts to true airspeed, which is way over here, we can see that we have a true airspeed of 444 knots. According to the airspeed indicator, that's equivalent to 77% of the speed of sound. The temperature outside the aircraft, actual temperature,
is 54 degrees centigrade below zero. That's the static air temperature. But the actual temperature sensed by the wing, which is called the total air temperature, is only minus 28 degrees. So notice there's a 26 degree difference between the actual temperature outside the airplane and the temperature felt by the airplane. High-speed air striking the airplane is supposed to compress, and as a result of that, it heats up a little bit. So the temperature the airplane feels is warmer than the actual temperature outside the airplane. Cleared to 410, good. Climb first, please. And now they're leveling at 41,000 feet. We'll let the airplane accelerate to its normal cruise speed of Mach 0.77. At this altitude, each engine is burning 600 pounds of fuel per hour for a total of 1,200 pounds per hour. That converts to 176 gallons per hour, which isn't too bad considering the speed that we're getting and the load that we're hauling. Also, it might be interesting to note that here at 41,000 feet, the cabin is pressurized to about 6,200 feet above sea level. It's pretty comfortable. Also, you might want to take a look at the power gauges once again. Notice that right now the turbine speed is 95% and the fan speed approximately 96%. In no way does this indicate that the engines are producing 96% of power. As a matter of fact, it's important to realize that turbine engines, just like naturally aspirated piston engines, lose power with altitude. As a matter of fact, up here, these engines are probably producing less than 25% of the power they'd normally produce at sea level. Although this airplane has a ceiling of 45,000 feet, you generally don't want to fly above 41,000 feet for the simple reason that above 41, both crew members have to wear oxygen masks. And the reason for that is, in the event of a sudden decompression of the cabin, it was felt that you couldn't down quickly enough into a breathable atmosphere from above 41,000 feet. By the way, one thing I found to be very interesting, in most of the big airplanes I've flown, the jetliners, hand flying at 41,000 feet is an ordeal. But this airplane flies very nicely at 41, no problem at all. Very stable, very solid.
You ready to go down?
Yeah. Okay, we're at 41,000 feet. We've just been cleared down to 37,000 feet. Now, here's something you wouldn't do in a piston-powered airplane. We're going to bring the throttles all the way back to idle and glide down. If you did that to your piston engines, especially if they were turbocharged, you'd have to send them to the shop for overhaul. You don't have to worry about shock cooling a jet engine. We're descending in our cruising speed of Mach 0.77. You notice we're only going down 1,500 feet a minute at a true airspeed of 436 knots, which points out how clean the LearJet is. In fact, all jet airplanes have pretty outstanding glide ratios. Okay, we're descending in Mach 0.76, and ATC wants us to go down a little faster, so we'll go right to the barber pole, which is Mach 0.8 plus. We're descending right now at our cruise airspeed of 0.77 Mach, but if we kept doing that, we'd wind up going too fast in terms of indicated airspeed. So now we'll transition to an indicated airspeed of 250 knots. By maintaining a constant airspeed as we descend, our true airspeed will very slowly reduce. Right now we're descending at 290 knots indicated airspeed, going down about 2,300 feet per minute. Now if we maintain a constant indicated airspeed as we go down, we're going to have to gradually keep raising the nose to maintain the same indicated airspeed, because as the air gets denser, the indicated airspeed wants to increase. So we have to gradually keep raising the nose to keep the airspeed in check. Consequently, the sink rate will also decrease as we descend, and that's when we descend at a constant indicated airspeed. Okay, we're descending at Mach 0.79, and watch what happens when we put the spoilers on. Down the nose a bit more, We've pegged out the bottom of the vertical speed indicator. Hard to say how fast we're going downhill. And you can tell by the winding of the altimeter that we're going down at a pretty good rate. You have to be very careful in a jet airplane. We're supposed to level off 4,000 feet. If we kept this up very long, we'd go shooting right through our altitude. So at this point, I'll raise correction for the spoilers. Bring the nose up so that we don't exceed our maximum allowable airspeed. And we put it down to 8. Okay, we're still gliding, power off, but at a pretty good clip. We're descending almost 300 knots, going down 2,000 feet a minute. If I slow the airplane up to 250 knots, it'll take forever to bleed the speed off by raising the nose. The rate of descent will decrease rather dramatically. All of this helps to point out that the LearJet, in fact any jet-powered airplane, has a much better glide ratio than a propeller-driven airplane. This is because when you pull the power back on a jet, you don't have a big propeller acting as a speed brake to slow you down and drag you down. A lot of jet airplanes have glide ratios of up to 20 to 1. Or most airplanes, piston-powered airplanes with propellers have glide ratios of only between 8 and 12 to 1 on the average. ATC has just requested that we reduce airspeed to 220. Now look how long it takes to slow down. We're holding our altitude, indicating 270 knots. Just watch the airspeed very slowly bleed down to 220. Takes forever to slow down. Remember, the power is off. The engines are only idling. We're back to 260 now. Takes a long time to slow up in a LearJet. In fact, the difficult thing is to go down and slow down in any jet airplane, particularly this one. Okay, now watch how quickly the airplane accelerates. It'll accelerate a lot better than it'll slow down. We're indicating 240. Just added some power to increase our speed at flight level 220. The airplane accelerates rather well. Heading 360 and down to 16,000. Well, on most piston engine airplanes with propellers, you pull the power back, the nose pitches down. But notice, pull the power off, nothing happens to the nose of the jet airplane. It'll lose a little speed, and then it'll start to go down. I can add a lot of power to it, and there's no tendency of the nose to rise. The speed will increase, and as a result of the speed increasing rapidly, there'll be a slight pitch up. But there's no tremendous pitching moments as a result of adding or taking away power. Losing an engine in a LearJet is not particularly traumatic if it doesn't happen as long as it doesn't happen on takeoff. Because the engines are so close to the aircraft centerline, there's very, very little yaw experienced during an engine out. For example, I'll roll out on a heading of 195 degrees, and I'll retard throttle of the left engine. Just watch the directional indicator. I'm just maintaining a wings level altitude. We haven't yawed more than a couple of degrees. Okay, right now we've placed the aircraft in the landing configuration. The gear is down, the flaps are all the way down, and I'm flying at 130 knots. What I'm going to do is slowly reduce the power and attempt to maintain altitude. And we're going to stall the airplane. And remember, a stall, according to the FAA, is the first negative or adverse symptom demonstrated by the airplane. We'll feel the stick shaker, might hear it, and of course the stick wedge forward. Now remember, the airplane has full flaps, the gear is all the way down. When the airplane stalls, I'm going to attempt to maintain altitude by simply adding power and without raising the flaps of the landing gear. This airplane presumably has enough power to stall and recover in the dirty configuration and maintain altitude. Let's see what happens. We're maintaining right here 16.5 down to 100 knots. There it is. Stick shaker full power. Lo and behold, we can maintain altitude, and the airplane is accelerating with the flaps all the way down and the gear still down. Okay, gear up. On the average in a jet airplane, you try to descend on what is called a 3-to-1 ratio. That is, you want to lose 1,000 feet for every 3 miles you have to go. For example, if you're up at 30,000 feet, it takes on the average 90 miles to lose the altitude. So just multiply your altitude times 3 to see how far out you have to begin your descent. Okay, we're angling toward the final approach course at Van Nuys. We're about 8 miles north of the airport, about to intercept the ILS final approach course. Got the flaps lowered to 8 degrees. Airspeed's down to about 170 now. And we'll go to 20 degrees of flap so we don't overrun traffic on final. Localizers coming alive. The landing gear down, please. Our reference speed for this landing is 120 knots. That's the speed we'll use on final with the gear down and full flaps 30 degrees. Okay, the flaps are all the way down. We've got the speed back to 120. There's one thing you don't want to do during the landing is to attempt to make a full stall landing in a jet airplane. It's so plain that it'll float down the runway and float and float before you realize all the runways behind you and you still haven't touched down. The idea is to fly the airplane onto the ground. Of course, we'll use a nose-up attitude. The power will be off. One thing that's really very irritating about this is, unfortunately, the hallmark of a pilot is how well or how poorly he lands an airplane. Well, just remember, I'm pretty green at this. I've only made a few before now, so I make no promises. At any rate, we're got the speed down to 120. Sync rate is 700-800 feet a minute. A little bit low on the dive slope, add some power. Right down to the ground. You get a few feet off the ground, you can start bleeding back on the power. But keep it going down. If you try to hold it off, it floats and floats and floats. That wasn't too bad. You notice we didn't use the reverse thrust. That's because there's a problem with one of the thrust reversers on this airplane, which needs to be attended to. Well, if you could look out the front window, you'd see that I used all the runway. I take advantage of whatever I have.
Well, I hope you've enjoyed flying this airplane as much as I have. Frankly, I've had a ball flying a $3.5 million rocket with wings. I'd like to thank the LearJet Corporation for providing us with this brand new Model 35A. And I'd like them to know that if at any time in the future, anywhere, they'd like me to fly this airplane again, I'd be more than happy to accommodate.
With a vacuum-driven attitude indicator, at what point in a normal coordinated turn is the pitch and bank error at maximum? 90 degrees, 180 degrees, or 360 degrees? The correct answer is number 2. 180 degrees is the point of maximum error.
In my over 20 years of private flying, I've never owned noise-reducing headsets or an intercom. Well, a few months ago, a friend of mine gave me a lecture on the hearing protection afforded by headsets. So off I went in search of the perfect intercom. After researching the units from a number of large and small manufacturers, I settled on an intercom from Sierra Electronics called the Quiet Flight. Now, this is a very difficult intercom to find and buy because Sierra Electronics is truly a mom and pop. You'll also rarely see it advertised. As far as size is concerned, the Quiet Flight mounted easily in the top of my glove box, not tying up valuable panel space. The faceplate can be ordered in a vertical or horizontal format for easy mounting in a number of locations. It contains a pilot and co-pilot set of jacks, so minimal aircraft wiring is necessary. In my installation, these go unused because the intercom is connected to remotely located jacks. The Quiet Flight can also be used as a portable with this handy carrying case and cigarette lighter adapter for power. The case will hold 2 headsets and includes a rechargeable battery power supply. Since we're an aviation video and audio magazine, I've asked our executive producer to sit in the cockpit with me to demonstrate the Sierra Electronics Quiet Flight.
In most intercoms, when one person speaks, all the mics are open. But on the Quiet Flight, only one mic opens at a time.
This really reduces background noise, especially when 4 people are on headsets. What about ATC priority? Well, in most intercoms, ATC and the cabin conversations reach the headsets at the same volume. Not so with the Sierra unit. An ATC priority switch allows ATC to override cabin conversations, so you'll never miss a radio call. Here's an example.
Bill, I was looking at this EGT gauge and wondering how it shows up at night.
Turn
Is it internally lighted or is the ambient light enough to see it? With the red light on in the cockpit, can you see those red needles?
On the other hand, during cruise, when you're just monitoring ATC, you can select that the cabin conversations override the aircraft radio. You'll hear ATC, but at a lower volume in the background. Many of the popular intercoms accept a music input, but none treat this valuable addition to a long flight as well as the Quiet Flight. First, they start with the headsets. Noise-canceling headsets lack 2 essential items. First, most are not stereo, and second, the earpieces really aren't designed for quality music reproduction. Now, Sierra Electronics rewires your present headsets or sells you new ones that are rewired for stereo sound. And they replace the earpieces with transducers of a high fidelity type.
Music can come from any portable tape player or CD unit, and it doesn't cut out on ATC conversations or cabin conversations. It merely lowers the volume.
Now, there's a big difference when you're listening to your favorite CD and it's interrupted by ATC radio chatter with other airplanes. Not so bad, however, when it merely lowers in volume.
So as you can see, it is possible to have music, cabin conversation, and ATC all taking place at the same time.
True, but I've sort of set a personal minimum that I always stop the music when I'm in a busy terminal area or right before I begin a descent.
A final front panel switch allows the co-pilot mic to be selected by the push-to-talk switch for radio transmissions. Handy for 2-pilot operation.
All of this doesn't come cheap, however. The unit list price is $395. Now, I've seen the Sierra Electronics people at most of the aviation conventions the last 3 or 4 years, and you can pick up show specials at about $125 off the list price. To rewire and rework the headsets for stereo, about $65 each. And the installation is normal for any type of intercom. Now, I know all this sounds like a commercial for Sierra Electronics. This might be a good time to let you know that it's not. The new products and services that I show you on ABC's Wide World of Flying are my personal choices of items I think that you'd like to see demonstrated. As a matter of fact, I waited around for a show special to buy the Quiet Flight for my Baron. No matter which headset or intercom combination you choose, the benefits of noise reduction in the cockpit are enormous. I can't see how I've flown so long without them.
Excitement often is an elusive characteristic in aviation. For the vast majority of pilots, that's as it should be. Most intelligent aviators prefer to minimize risk whenever possible. Safety is the name of the game in general aviation, and lately, economy has become a byword as well. Certainly one of the safest airplanes in the world is the reliable old bird directly behind me. It's Cessna's venerable Model 182 Skylane. The airplane I just climbed out of is the Skylane's father, the tail-dragging Cessna 180 Skywagon, one of the last four-seat tailwheel airplanes available. As you may have guessed, the big difference between the two is the location of the third wheel. The older 180 Skywagon drags the tailwheel, while the Skylane uses a nose wheel. The 182 behind me is a 63 model, nearly as old as I am, but that barely matters with Skylanes. No matter what the model year, pilots nearly always refer to Skylanes with reverence and affection, calling them good old airplanes and treating them with the same respect they'd normally bestow only on their favorite German Shepherd. The proof of the Skylane's phenomenal popularity, however, is in the flying. And this morning, we're going to fly not only the Cessna 182, but also this derivative Skywagon and the final evolution of the airplane, the Turbo Skylane RG. We'll start with the 180 Skywagon. The derivative Skywagon's conventional landing gear, high wing, good prop ground clearance, and copious power made the airplane an excellent bushbird. Ground maneuverability with the forecast and tail wheel was impressive, a major advantage when the runway was roughly non-existent. The 180's beefy engine was a basically bulletproof carbureted Continental 0470 that pumped out 230 horsepower and gave the airplane semi-stall takeoff and landing characteristics, no matter what the runway surface. The Skywagon's spring steel gear was unfaired and permanently down and welded, so cruise was only about 135 knots on about 13 to 14 gallons per hour, not the most efficient combination available. But Skywagon owners bought their airplanes more for what they could carry and where they could go than how fast and how efficiently they could get there. Skywagons were legitimate four-place airplanes that could be quickly converted to cargo configuration, then sandwiched into short strips.
The Cessna 182 Skylane's primary advantage over the tailwheel Skywagon is the obvious one, a nose wheel. The Skywagon can be a demanding airplane to handle in stiff crosswinds. Conversely, the 182 Skylane is a comparative pussycat during transitions from ground to air and back again. Camarillo traffic, Cessna 3133 uniforms, taking the active at Camarillo.
Pilots of average ability could fly the 182, or more specifically, could take off and land it. Once in the air, they could plan on nearly 1,000 feet per minute climb from sea level with a full load. In keeping with its modern image and general appeal, the Skylane was updated to a swept tail in 1960 and a rear window in 1963. Externally, these were the only major changes to the Skylane's appearance. As you can see in this split screen of our 63 model on top and a 1983 Skylane below, there's very little physical difference evident. There were some changes: a redline reduction to 2,400 RPM, an improved cowling, aerodynamically clear wheel pants, and a more pointy spinner. But generally speaking, the Skylane was such a good airplane to begin with that it matured by remaining the same. What has helped the Skylane sell nearly 20,000 copies is a combination of good performance, a plentiful payload, easy handling, and impressive reliability. The engine is a major key to the airplane's success. Though it's not particularly efficient, specific fuel consumption runs about 0.48 pounds per horsepower per hour. It has a good reputation in the Skylane installation. In cruise mode, the 0470 drives the Skylane along at 135 to 140 knots, about the same as most of the older 200 horsepower retractables, but without the complexity of folding feet. With 79 gallons in the tanks, maximum range at economy cruise is about 850 nautical miles plus reserve. Certainly not spectacular, but enough to cover most missions most of the time. The newer airplanes are worth an extra 5 knots or so because of slicker aerodynamics, and larger fuel tanks extend the range an additional 100 nautical miles. Perhaps the Skylane's best feature is its creature comfort, even for relatively large creatures. The cabin is 32 inches wide by 49 inches tall, but it looks larger because it expands at the top. Most of the time, the big cabin can actually accommodate 4 full-size folks. Our 63 model is owned by Plane and Pilot magazine, and appropriately, it's been totally refurbished, and its heavy load of options limits payload to less than 4 humans. Specifically, payload is 610 pounds with 79 gallons of fuel aboard, but more typical Skylanes can carry full fuel and full seats too. What has endeared Skylanes most to pilots for the last 30 years is their remarkable stability. The airplanes are stable as a table and generally fly as if mounted on rails. For that very reason, they make good IFR platforms, are undemanding in turbulence, and generally do everything but fly themselves. The other side of the coin is that they're not exactly the most responsive of flying machines. Control pressures are heavy in virtually all modes, roll, pitch, and yaw. Roll rate is only about 50 degrees per second, and you'll really realize just how heavy the elevator is the first time you try to go around without retrimming. The heavy controls and 500 to 700 pounds extra weight are perhaps the biggest obstacles in checking out Skyhawk pilots in the Skylane. If you do remember to keep the trim roll moving, however, a 182 is a fairly easy machine to land. The big flaps hang down 30 degrees at max extension, though, and that big 6-cylinder engine out front is heavy, so it's possible to run out of elevator for flare and have the airplane drop out from under you if you're not careful. Most of the time, however, it's possible to ground the Skylane smoothly in minimum distance. If you're really on it and wanting to approach at 60 knots, you can stop the airplane in a very short distance, in this case, about 400 feet. Aircraft Price Digest, the standard pricing guide for general aviation aircraft, suggests you can buy a 1967 or earlier Skylane for about $20,000. Or if you're willing to go to $30,000, you can buy a good 75 model or earlier. Plane and Pilot purchased this Skylane back in 1977 for a mere $10,000, but today they have at least 4 times that much money invested in it. The Skylane has proven a highly adaptable design with variants that have included retractable gear and turbocharging. The Turbo Skylane RG was built from 1979 to 1986, and it is perhaps the ultimate extension of the Skylane idea. As with the 210 and other Cessna single-engine retractables, the wheels fold into the belly, and the result is somewhat better climb and about a 15-knot cruise advantage over the standard Skylane. In order to find room for the nose wheel and realize the benefit of turbocharging, Cessna switched engines to carbureted Lycoming 0540J, essentially a D-rated version of the engine used on early 260 horsepower Comanches and Aero Commanders. The Lycoming is rated for 235 horsepower rather than 230, but the difference in power is barely noticeable. Turbocharging does make a big difference in cruise, though, especially if you need to top tall mountains. Level and trimmed at 20,000 feet, the Turbo Skylane RG can turn in 185 knots, a full 45 knots better than the stock Skylane's best effort. Keep in mind, though, that the T182 RG costs about 30% more than a similar vintage stiff-legged Skylane. All of the 182 series Cessnas have earned places for themselves in the ranks of the world's best airplanes. The Garden Variety Skywagon, its incredibly successful nose wheel variant, the Skylane, and the modern turbocharged retractable, the Turbo Skylane RG, have achieved their success because they do a variety of jobs well. They may not be the fastest, the most efficient, the best climbing, the longest range, or the most comfortable in their respective classes, but their jack-of-all-trades adaptability and easy handling qualities continue to make them among the most popular airplanes in the world.
A large jet aircraft has just landed prior to avoid weight turbulence. Where should you plan to become airborne? Before the touchdown point, at the touchdown point, or after the touchdown point? The correct answer is number 3. After touchdown, the jet stops generating wingtip vortices.
Many people are under a misconception about the Automatic Direction Finder, or ADF. Some people think the Automatic Direction Finder is the instructor in the right seat, while others think it's a special device to keep them from passing their IFR check ride. In reality, the ADF can be a very helpful tool if understood. In presenting seminars for pilots across the country, I've received consistent feedback that many instrument-rated pilots have real problems shooting NDB approaches. So in this segment, I'm going to focus in on two of the biggest problem areas: intercepting the approach course and wind correction. Let's review a few fundamentals of ADF navigation by referring to the NDB runway 30 approach to Long Beach, California. The approach consists of intercepting and tracking to and from the NDB on the 301 inbound bearing. Now, pilots can expect to be vectored onto this bearing. However, if radar is unavailable, then they would be expected to fly one of the approved non-radar routes shown here on the chart, either from Patter intersection inbound, from Albus intersection inbound, or from Mids intersection inbound, or from the Seal Beach VOR to the NDB by flying the approved non-radar route shown here underneath the VOR frequency box of Seal Beach. Under no wind conditions, you will be established on the 301 degree inbound bearing when your heading is 301 degrees and the ADF needle points straight ahead. As you pass over the NDB, the needle will swing to the tail and the descent is started to the MDA. Under no wind conditions, you'll be established on the 301 degree outbound bearing when your heading is 301 degrees and the needle points directly to the tail of the airplane. Now let's talk about the ADF equipment and develop a new way of referring to the numbers on the rotating card. When flying an NDB approach, set the card so the 0 reference is on the nose of the pictured airplane. As you read this card, I want you to think of the angles made between the needle and the nose and the needle and the tail. These angles will inform you of your position in relation to the desired course. If the needle is located here, we'll say the angle between the needle and the nose is 30 degrees on the left. If the needle is located here, we'll say the angle between the needle and the tail is 30 degrees on the right. Now I'd like to share with you two key principles that will help you intercept and track an NDB bearing. Principle number 1 states that while on a constant heading, the ADF needle will always rotate toward the bottom of the pictured airplane. Now, for all you CFIs out there, the only exception to this rule is when the winds are too strong for the angle of intercept. Now, the ADF needle is rotating toward the bottom of the pictured airplane because any NDB station in front of us will eventually end up behind us, as this radio antenna is doing here. Another way of stating this is that during course interception, the angle between the needle and the nose will always increase, and the angle between the needle and the tail will always decrease, as long as the heading is held constant. With a constantly moving needle, how will you know when you're on the desired approach course? Principle number 2 states you're on the desired course when the angle the approach course is intercepted at is shown between the needle and the nose if it's a bearing to the station, or between the needle and the tail if it's a bearing from the station. Intercepting the 301 degree inbound bearing on a heading of 270 degrees gives you an intercept angle of 31 degrees. Airplane A shows a nose needle angle of less than 30 degrees, and you know this will eventually increase to 31 degrees as in position B. If you flew beyond the inbound bearing as in position C, the angle shown will always be greater than 31 degrees and you will never intercept the course. When the 31 degree intercept angle is shown between the needle and the nose, you would turn inbound on course. You're now on the 301 degree bearing to Long Beach inbound. Another way of identifying what bearing you're on to the station is to imagine the ADF needle superimposed over the heading indicator. This imaginary ADF needle will then point to the bearing we are on to the station. Here at the intercept point, the airplane is exactly on the 301 degree inbound bearing. The overlay technique can be used anytime you want to know what bearing you are on to or from a station. Let's say we're outbound from the NDB on approach to the left of the 301 degree bearing. The ADF needle will show a slight right of tail deflection on a heading of 301 degrees, indicating the course is to our right. Let's choose to intercept at a 29 degree angle on a heading of 330 degrees. What will the ADF read when we're on course? Initially, the ADF will show an angle greater than 29 degrees as in position A. Since the needle always moves to the rear, it will eventually show the 29-degree intercept angle as in position B. If you flew across the desired bearing as in position C, you would show less than 29 degrees between the needle and the tail, indicating that you've flown across the course. When the 29-degree intercept angle is shown between the needle and the tail, you would turn to 301 degrees. I would use a few degrees of lead for the turn to prevent overshooting the course. We're now on the 301-degree outbound bearing. Back at the intercept point, using the overlay method, you can confirm what bearing you are on from the station by imagining the ADF needle superimposed over the heading indicator. The tail of the imagined overlaid needle will point to the bearing you are on from the station. Here at the exact point of intercept, the tail would point to 301 degrees. Okay, that wraps up my tips for intercepting the approach course. Next, let's look at the problem of wind correction. While inbound or outbound on course, it's possible to have a crosswind. In this instance, while holding the 301-degree inbound heading, the airplane is blown to the left of course, as is reflected by a right needle deflection. We may have a right crosswind here. I usually let the needle drift 5 to 10 degrees before attempting to re-intercept the course and apply a crosswind correction. ADFs have a tendency to wander, and I don't want to be chasing false crosswind indications. I also want to be cautious about false crosswind readings caused by increased sensitivity and rapid needle movement when close to the station. If needle movement indicates a bona fide crosswind, then re-intercept the course as was previously discussed and apply a wind correction angle. Usually about 20 degrees is adequate for re-interception. Apply what you think may be an adequate wind correction angle, say 5 degrees to the right. If a 5-degree wind correction is adequate to correct for drift, then the needle will show a steady 5-degree indication to the left of the nose, since the airplane is crabbing to the right of the station. Just think of this as the right crosswind requiring a constant 5-degree intercept. The same crosswind procedures apply when flying outbound on an NDB bearing. Tracking from the station with a 5-degree right wind correction will cause a needle deflection 5 degrees to the right of the tail. That's it for wind correction. Here's another problem you may encounter.
Sometimes it's possible to become disoriented while shooting an NDB approach. If this happens, follow this procedure. Head the airplane in the direction of the desired bearing. In this case, it's the 301-degree bearing. Look at the ADF and see where the course is located. It's either to the right or to the left of the airplane. Intercept in the appropriate direction using an adequate intercept angle. In this case, you'll intercept using a 30-degree angle, and you'll know you're on course when 30 degrees is shown between the needle and the nose. There are a few other things pilots should keep in mind while shooting an NDB approach. ADFs are not all that accurate when turning the airplane. Read critical values only when the airplane is in straight and level flight, and always make sure the DG is accurate prior to shooting an NDB approach. Activate the test mode a couple of times while on approach. This checks to see if a strong signal is being received and the needle isn't just stuck in some position. Turn the volume up on the ADF while shooting an NDB approach. This lets you know that the station is still on the air. Also, remember that NDB navigation is not very accurate. When looking for the airport at the missed approach point, look to the right and to the left instead of just straight ahead. I feel that if you are going to shoot an NDB approach, that you should be very familiar with the accuracy of the equipment that you are using. I certainly will not shoot an NDB approach to minimums with equipment and at an airport that I'm not familiar with.
One of my most annoying pilot chores is updating jet charts. And this is just a medium-sized package. Well, a Boulder, Colorado company has helped to solve that problem with a unit called the Lasertrak. Now, it stores all the jet terminal charts, SIDs, and stars on a 5-inch compact disc, or CD as we know it. A new disk is sent every 28 days, and that serves as the update. It has the capacity to contain all the chart information for the entire Western Hemisphere. Now, what does all this do for the pilot? Well, it's a complete flight planning station that produces the highest quality graphic weather maps and, of course, weather information from the leading vendors. Now, on top of that, it gives you what they call a flight pack, which contains the JET terminal charts for airports that you enter into the Lasertrak computer. Now, the model FP100 weighs in at 20 pounds and replaces my almost 40 pounds of JEP and NOS charts required to maintain full U.S. coverage. The rugged case contains a full alphanumeric keyboard, an internal 1200 baud modem, an accessory tray with all the necessary cabling, and to print the detail necessary for JEP charts, this high-resolution thermal printer. For the last month, I've been using the Lasertrak. When I first read about the unit, I thought it was a device that you placed in the airplane and produced charts on demand. That brought up all kinds of questions about reliability, speed, ease of use. Well, Roger McElvoy, the Eastern Regional Sales Manager for Lasertrak, gave me a short checkout. And he said, no, the unit is a flight planning station that should be used prior to each flight. He was absolutely right. You only carry the Lasertrak in your airplane for emergency chart production. Let me demonstrate how you'd use the Lasertrak to plan a flight from my home base at Teterboro to the Chicago area. First, you might want to determine what Chicago airport is the closest to your destination in that large metropolitan area. The compact disc comes to the rescue, since it contains the full Rand McNally city database. You can determine all the fields that meet your criteria within a 30-mile radius of the geographic center of Chicago. I've told the Lasertrak to look for all Chicago area airports that are 2,500 feet or longer and are IFR. The unit then prints this map showing these fields and listing their important information. Now I'll enter the flight plan mode and input my route of flight along with any other pertinent FAA data. The Lasertrak has already been pre-programmed with my aircraft performance data on the Beech Baron. Now, in the case of this often used flight, it's going to be from Teterboro to Palwaukee. That's a small airport just north of O'Hare. The computer has stored a previously used route and calls it up automatically based on the departure and destination airports. This saves a lot of time and trouble. Now let's look. Altitude okay. Alternates okay. I'll expect a 5-minute ATC delay. And instead of entering my departure time, I'm going to enter the arrival time, and the computer will calculate what time I have to leave to hit that arrival time. 180 knots for my Baron. Wind component, let's say a headwind going westbound, minus 20 knots. 2 passengers. 816 pounds of fuel on board. 45 minutes of fuel reserved. And no remarks. I have the option of entering up to 5 emergency airports. In this case, I think I'll put in Benton Harbor, Michigan. That looks like a good possibility in case headwinds are more than forecast for stopping before setting out across Lake Michigan. The Lasertrak now searches its immense database for intersections, airports, airways, and then prints a trip confirmation chart. Now, this gives you a scaled and compass-oriented route for the flight, along with all the computed data to file the flight plan and fuel burn information. If you confirm this is okay, the FP100 prints a flight pack and nav log for the entire trip. Now, this pack contains all the jet charts needed for the flight, including SIDS and stars. Each chart takes about 14 seconds to produce, with a short duration between charts. Now, the whole idea behind the flight pack is to eliminate printing charts in flight. By fan folding this strip of charts on the perforations, you end up with a convenient and complete bundle for use in the aircraft. Included in this package is a nav log to aid in flight planning en route. Both the trip confirmation and the nav log are lacking in detail on purpose. The unit is not designed to replace sectionals or en route charts, so Lasertrak has purposely left off a lot of detail so that you won't be tempted to leave those maps at home. Now, what doesn't the FP100 contain? Well, at the present time, no fold-out charts are printed. This means that the taxi and airport charts for O'Hare must come from your binder. The Lasertrak FP service contains one binder with the disk. In this binder are the fold-out charts, en route, area, and TCA pages, and all the front section JEP information on preferred routes, meteorology, and so forth. To really appreciate the total flight planning center concept, Lasertrak's built-in modem completes the process by obtaining aviation weather. The high-quality printer enables you to get the fanciest graphic maps from the leading vendors like WSI and Lockheed's data plan. These two services are built into the weather program, allowing auto log-on and predefined requests. Since it's a dumb terminal, however, any computerized weather service can be accessed. In addition, there's a full-function calculator and a database lookup mode, which prints out lat-long information. Now, where is all this going? Well, the CD disk can contain much more data than I've just demonstrated. For instance, you could get information on hotels or FBOs at your destination. And software changes, never have to send the unit in for those. They come along with your chart update disk every 28 days. Now, from my evaluation for over a month, I found the Lasertrak to be a piece of high technology, designed for the corporate operator. As a light twin owner, I'm not sure I want to bear the expense and take the time to use a Lasertrak for what are usually shorter flights. At the same time, the company believes that high-performance singles and light twin operators are part of their marketplace. So if you've ever said you'd give anything to get away from having to update your JEP charts, it's now possible. The cost? Around $6,700 for the Lasertrak FP100 and $945 a year for the update service.
Which instrument gives you the most pertinent information for bank control in straight and level flight? Number 1, turn and slip indicator. Number 2, heading indicator. Or number 3, attitude indicator. The correct answer is number 2. The Instant Flying Handbook states that for straight and level flight, the heading indicator is the primary instrument for bank control.
During pre-flight, pilots have learned to check for the presence of water in aviation gasoline. But what about jet fuel? Well, jet fuel and a reciprocating aircraft engine is a dangerous combination. Even a small amount of jet fuel can literally destroy the engine through the explosive powers of detonation. So even a small amount of jet fuel in the tanks is totally unacceptable. Here are a few tips to help identify the presence of jet fuel in aviation gasoline. Avgas mixed with 10% jet fuel still looks like avgas, but it's possible to smell jet fuel in the sample. Now, if you rub it between your fingers, the mixture will feel very slippery to the touch. To more precisely detect the presence of jet fuel in aviation gasoline, try this simple evaporation test. Place a drop of the fuel sample on a white piece of paper. If it is contaminated with jet fuel as little as 5%, then the jet fuel will form a halo or small ring that will be visible as the avgas evaporates. Now, if the sample is all avgas, it will evaporate and disappear completely, leaving no stain. Now, if you own a Piper Cub, it's highly unlikely that line personnel will mistake you for being turbine-powered and put jet fuel in your tank. However, today's high-performance single and multi-engine airplanes can easily be mistaken for turbine-powered aircraft, especially if the word turbo appears on the side of the airplane. Well, fuel restrictor rings, along with alerting decals and very, very careful supervision of line personnel, is really the pilot's best bet in preventing an accidental fueling with jet fuel.
This is Tsunami with a 3,000 horsepower supercharged engine. It's designed to be the fastest piston-driven airplane ever. Noted exhibition and movie pilot Corky Fornoff brings you this story.
I'm here in Chino, California with Steve Hinton, who will fly Tsunami at Reno. And I've just asked Steve to give us a brief cockpit checkout.
You can see the cockpit of Tsunami was built really for speed. We don't have any avionics to talk about. It's all engine and flight instruments. The throttle quadrants over here on the left, everything's kind of right in front of you. You can see your throttle, propeller, and mixture control. The throttle, for instance, 60 inches on this engine and 3,000 RPM is what the engine was designed to operate at originally. But we're capable of 110 plus and 3,800. Where originally the engine at 61 inches and 3,000 would put out 1,500 horsepower. At that power setting right there is a little over 3,000 horsepower. Of course, we don't intend to run it there, but it is capable of running there. The communications right here for ground crew and race control. This is what keys the mic. Manifold pressure, RPM, airspeed. We fly about 130 knots on final, and we race at around 380 knots indicated. And at Reno, that'd be good for 445, 450 mile an hour laps. Our coolant temperature and coolant spray bar. And what this is, the spray bar sprays water across the radiator, and it allows us to operate at all this extra horsepower without overheating the engine. And we can pump up to 6 gallons a minute across the radiator. This is called a 3-in-1 gauge, and this keeps monitor of our fuel pressure, and oil temperature. Oil temperature we can control with the spray bar and keep it where we want it. And fuel pressure, we make sure it's operating high. If you get fluctuating fuel pressure, you could be cause of a detonation and backfire with a lean mixture at that high power setting. As you can see, everything's kind of gauged to be looking out. So we have really important immediate problem instruments right up. Coolant temperature, oil pressure, all kind of right in view as we're looking out of the cockpit. So everything is just built where you can just kind of touch it and feel for it without having really to look at it.
Tell you what, we're going to get out of your hair, give you time to get this thing all set to go, and we'll see you in a month in Reno.
Okay.
Thanks, pal.
Thanks.
Reno 87 arrives with the fans anticipating the fastest air races ever seen. Qualifying is completed, and the results are stunning. Strega, a highly modified P-51, has qualified at 466 miles an hour, a new world's record, and Tsunami has qualified at 464, reportedly with quite a bit more throttle available. Heat races are scheduled for today and Saturday. Then on Sunday, the 8-lap gold race will decide it all. Frankly, a lot of people are wondering, is this Tsunami's year?
One of the dreams I've always had is to build the world's fastest prop-driven aircraft. And this dream was kind of nurtured when I was involved with Darrell Greenemeyer and Steve Hinton with the Red Baron. So that was kind of the manure for the seeds that were planted earlier. When John Sandberg and I got together at Tonopah for the world speed record attempt with the Red Baron, we started talking about a small, lightweight airplane that would be wrapped around a very reliable engine, which turned out to be the Rolls-Royce Merlin. When we started talking about this airplane, it was just conceptual at first. At the Reno races in 1979, I brought some drawings of what the airplane might look like. At that point, he says, well, when can we get started? Well, I said, well, geez, I don't know. It's sounded like a big proposition to me, but we started building the airplane, all the tooling and so forth. It took about 1.5 years just to establish the tooling. When we started building the aircraft, everything just went along very smoothly. Because you don't really find out all the problems until you start to assemble it. I would say the biggest labor-intensive part of the aircraft was getting the landing gear to fit in the aircraft. We have a hole in the wing. Now we have an existing landing gear, not a gear that's designed for the airplane, but an existing aircraft landing gear, which essentially is a Piper Aerostar with LearJet brakes and wheels. And we had to mount this in space and actually get it to fit inside the wing and to swing properly so that it would clear everything. So we had to build tooling to simulate the trunnions of the landing gear. And this took, I would say, about all of 3 weeks to actually do. And we probably retracted the gear 200 times by hand. My partner has huge arm muscles now. But I would say that was probably the most single labor-intensive program involved with Tsunami. Everything else seemed to go relatively smooth. It was just labor intensive and took a long time, especially if you want to do it right. Now that we have the airplane up at Reno, we have done some flight testing since we've been up here. Everything is really matching the numbers. In fact, it's exceeding the numbers that we predicted for the airplane, and we're very happy with it. So as long as we still have what we think is systems maturity, we should win the race. Well, that's why we're here in the first place.
The real competition for us out here today is obviously Strega, which went very fast in qualifying. Dreadnought has been dominating the races for the last few years, and it's a very, very, very strong contender. Lyle Shelton's with Rare Bear has come along very strongly this year, and we're looking at some heavy competition from him. And of course, Stiletto has always been a heavy contender. We plan on going after the speed record in July of 1988, probably at Bonneville. I hope to set the record at about 520 to 525 miles an hour. I'll be doing that personally. The racing is being done by Steve Hinton.
Well, today's Friday. We qualified second at 464 miles an hour. We think we've got a lot left in the airplane. We qualified at the power setting that we set out to qualify with. Racing strategy is going to be to try to stay out in front every race. We're expecting a lot of pretty stiff competition from everybody, especially the Dreadnought race number 8. He'll be the one to beat. He's got the one with a track record. He'll be able to probably reliably go fast every single lap. So I'm not really sure what their strategy is yet at this time, but I have a feeling they'll be kind of clipping on our heels the whole time, trying to wait for us to make a mistake.
Well, as far as what we did this year, preparation, the primary modifications, we did our airplane. We had to add additional oil cooling for the engine, larger engine, the addition of the Pratt & Whitney 4360, the Skyraider prop that we modified, and the tall tail to keep the airplane going straight into high power. We feel that we can run 450 and run the whole race and have some reliability, and we have a good chance at add another victory to be a third-time national champion. But some of the other airplanes here, like again Tsunami, has exhibited some very fast speeds in 460s, and in my opinion, they do have reliability at those speeds.
What we started out with here was a North American P-51D model that was manufactured in 1945. We took the airplane and completely stripped it down to no components whatsoever in it, and then we started modifying on our way, building it back for a full blown air racer. We've changed our scoop, the air intake scoop that lets the air flow across the radiator. We've tucked it completely way up. We've modified the canopy, cut it way down. We've changed the angle of incidence on the tail, the whole tail plane. We've smoothed up the wings where they're just like glass. The rest of it really has to do with the engine, which is a highly development type engine. It's taken us quite a while to really get it on board the way we want, and it seems like it's working out real good for us now. Our strategy for the race here at Reno is, of course, to qualify very good, which we did. We qualified at 466 miles per hour around the 9.2 mile course, which was a new record. We want to run nice and hard all week long. We want to, if our engine is looking like it would like to lay down on us, we want to know it early. In other words, we want to run good and sound each day so that we can take all the engine vital signs after each race. If it starts to lay down a little bit, we want to know that so we can repair it. We want to be in top form for the goal race on Sunday.
Just this last year, we've done a cleanup on the airplane by reducing engine cooling drag, oil cooling drag. We have slicked up the wings. We've straightened the wings. We made the airplane slicker where it just slides through the air quite a bit faster. We've got a rare propeller that gives us about 10 knots. We've picked up at least 15 knots on the airframe just this last year from doing a lot of small modifications.
Stiletto is a highly modified P-51 that was built only for one purpose, and that's air racing, and to be the national champion at the Reno Air Races. The wings have been clipped approximately 10 feet. They're now 28 feet long, vice to 38 feet. The radiator's been moved off of the belly, which you notice on most Mustangs have a belly scoop. The radiators have been moved into the wings to reduce the drag. we think we can run the full race at a fairly low power and still be ahead of everybody.
Well, the time has come for the talking to stop and the flying to start. Today's Gold Heat race is 6 laps, and it looks like nobody's going to be holding back. Every pilot is going to be pushing to see who's fast and who can last. Strega and Dreadnought jump out to an immediate lead, with Tsunami trailing in 3rd spot. With lap speeds in the 450-mile-per-hour range, this heat race is already the fastest race ever run at Reno. And this is just a shakedown. Steve Hinton reports that Tsunami is having some sort of a temperature problem. He limits power to avoid engine damage. Strega takes the race, leading wire to wire. Dreadnought is 2nd, and Tsunami is 3rd. As Tsunami is rolled back into the pits, the crew is concerned. Why is the oil temperature so high? The prime suspect is radiator cooling.
It won't go down, it won't go through the radiator. It's going forward, blowing out the seam, mixing with the oil fog, and turning peanut butter back here.
Steve, can you give us a recap of the race you just flew?
Sure, yeah. Well, the Friday first heat race, we started the race, power setting we wanted to run, and basically we're feeling everybody out, and we went to kind of advance our position. And it's going to require just a couple little changes on the airplane, though. We're very happy with the airplane, though. That was a good test we had with it.
Nothing really major, though.
Oh, nothing major at all. No, if it was Sunday, it would have been a different story. But I'm trying to stay conservative, so to speak, you know, the airplane, so we can come back and talk about it instead of have to fix it.
Tsunami's crew has had a long night, but they think the cooling problem has been fixed, and they're ready for today's heat race. This race, like every other unlimited race, is paced and started by Mr. Bob Hover.
Bob, we know you have a great responsibility in starting the races and caring for the safety and if there are any emergencies. What we'd like to know is what specifically do you look for to start the race? And what do you look for in the pilots to know how to handle the safety aspect if there is a problem?
Well, Corky, the thing we're really interested in more than anything else is just what you stated, safety. And the idea is to get them down that chute in an orderly manner and turn them loose with a reasonable separation. And from that point on, my responsibility is to talk the fellas down. I'm sitting in a calm, collected cockpit with no concerns about anything except helping someone out should they need it. So if you can, that's the fun I get out of it, is helping and assisting people.
Chuck, we know that you've been here for a few days and enjoying the show. We'd like to know who you think's going to walk off with the goal.
There's a lot of luck in this mechanical strain that they put on these airplanes, and it depends an awful lot just the integrity of the engine, how well it holds together when they really run it at max power.
We know that you've watched it from the pits, and we understand you went out to the pylons. What was your view from the pylon?
Well, I had an invite to go out of the pylon and look at it, and I didn't think too much about it when we went out there. But I'll tell you what, I was standing there, I wasn't really expecting what's going to happen. I tell you what, I swear they flew right between my ankles. And the power and the speed and the precision with which they came by was just incredible. It totally blew me away. I haven't seen anything like that. Wish I could find words to describe it.
Well, the P-38, you know, is a very historic airplane and was really built as a pursuit airplane to shoot down enemy aircraft. As a racer, it's delightful to fly, but it's not the fastest airplane on the track.
Bob, why don't you tell us about this unique airplane?
Well, it's a Yak 11 made in Czechoslovakia. It originally had 700 horse, and we've converted it slightly to 2,500 and skinned it. And it's a fun airplane. It started out being a trainer, and we're going to try to make a racer out of it. I don't know whether we're going to make it or not, but we're trying.
Mr. Poperizny, could you tell us what the significance is of air races in general aviation?
Well, there's a very close parallel. Most all of the people that are involved in this sort of thing are general aviation people. And it offers the public a great opportunity to get closer to aviation. As we well know, most of the major airports are fenced in, and the people are fenced out. It offers our public a taste of the real part of aviation.
What we look for before a race is specific amounts of spray bar, ADI, and the fuel load.
before we call anything that has been looked at and is questionable, is brought to my attention or to Jack's attention, because we can all miss things. And the confidence of the pilots is what we have to maintain. If Steve has any question mechanically about the aircraft, we show him whatever we found. We don't hide anything from Steve because his confidence has to be protected. If he doesn't have confidence in the crew, he can't fly a good course. And I trust Steve, and he trusts me. I trust the crew, and we all have to work as a team. Each individual can't do it alone. He and I have a little thing about God, and I say, as I told the other people, I said, the last thing I do, I'm powered up, so I say a prayer to God. I said, don't let Steve get hurt. We can always replace the airplane. And it worked so far.
Well, today's Saturday. It's our second day of racing. Our strategy today will be like it was yesterday. We want to be out in front, even though we weren't yesterday. But yesterday was really our first good race we've ever had on the airplane, and we learned a little bit more about it. And today I think we'll go a little bit faster, and if they can keep up with us, fine. If they can't, fine. Yesterday we started out, I was a little amazed that Strega was holding its position out in front. I head back there a little bit because I really expected to see some lights coming out of his airplane. Just because I know how hard he must have been running his engine. And like we had talked before, real tribute to those guys to be able to perfect that engine. They're really doing a great job keeping that thing alive. And so we're going to count on them being there on Sunday, where yesterday, really, I didn't think they were going to do that. Anyway, today we expect to go a little faster. We're very confident still.
We're going to run a little harder than we did yesterday. See if we can keep them honest. We would like to run faster than we did yesterday, about 5-6 miles an hour. We had a little problem with oil cooling yesterday, but that's resolved now, so I think we'll be all right.
The engines fire up and the fans are ready. It's another 6-lap heat race, and the Tsunami team would have nothing better than to show the world that their ship can really do when everything's working right. But of course, there's a few other people with the same idea, and it's clear that being able to go the distance is a key concern. Strega takes the lead in the first lap, and Tsunami in third. It's a carbon copy of yesterday's race. In the spray bay attitude, it's pretty clear that Steve is running more power. It's 7 miles. Lap speeds are running about 450 miles an hour, and the first 3 places are within seconds of each other.
And there he goes.
The big brown helicopter keeps up the pressure on Strega, but to no avail. Strega holds the lead. Hinton presses harder, increasing power settings, increasing speed.
Sandberg owned airplane that Steve Hinton is flying, the Tsunami.
But the cooling problem won't be resolved, and rather than risking damage to Tsunami's engine, on the last lap, Steve pulls out of the race.
Steve out of it.
Strega takes the checkered, leading wire to wire again. But RENO is just a fraction of a second behind. Steve's landing appears uneventful. But turning off the runway, he radios the crew that he has a problem. A major problem. The landing gear has collapsed. Just a small casting let go. One tiny part. But the damage is considerable, and Tsunami is clearly out of the race this year.
I don't think I even started the turn yet when I went. That real quick. Did it go? Stop.
Such a small piece, but such a big problem. good news is that the spar appears to be unbroken. Tsunami can be fixed. And in due time, she will race again. But for now, it's time to get her into a nice hangar. Lovingly, gently, the crew cradles their baby and heads for home. Hinton explains what happened.
Pulled out of the race, precautionary pull out, and came into land. And as I was rolling out, just getting ready to turn around and taxi back, the gear collapsed, the right gear. So it was really pretty anticlimactic, if you know what I mean. It was, yeah. Of course, you could say that's the way it goes, but I mean, it's such a big group effort, you know. I mean, just everybody's just, you know, we wait all year to do this, and then we come out here the day before the main event. Things are looking so good too, and going so good, and you just hate to. Nothing's in the bag.
You're looking at a winner. Not this year at Reno, but it'll be back, and it'll be back strong. We have 4 main contenders today in this race. Unfortunately, Tsunami won't be in it. The first airplane to watch, of course, is Strega. Strega's sitting there with a Merlin engine, which has amazed everybody that stayed together, and it's the fastest Mustang that's ever run anywhere. The second airplane is Dreadnought. Dreadnought is sitting there with a big 4360 engine, very reliable, very strong. The third airplane is Rare Bear, another one with a big round engine, a very reliable power plant. The fourth airplane is Stiletto. Stiletto out of Florida is a highly modified Mustang, again though with the Rolls-Royce Merlin engine. That's always had problems staying and going the distance. Next to that, the fifth airplane, we have the Super Corsair, another round engine, very reliable. It will go the distance and has won here before. To win this race today, you're going to have to go better than 475 miles an hour down the straightaway. And the overall time and speed is going to be somewhere in the neighborhood of 460 miles an hour.
We're going to turn and burn.
Are you?
Everything's fine. Should be a good race. Weather's beautiful. Engine's running strong.
No worries?
No worries at all. First thing we got to do, though, is take the start.
We've got some problems that have been coming in a little later in the race. I hope we've licked them, but we're going to do our best. And if we don't win it this year, we're coming back and we're going to win it next year.
I don't know what to think, really. You know, the Dreadnought is still the one to beat as far as I'm concerned. You know, he's right there, right with Strega. If Strega holds together, it appears to me that he might have the edge, but on the other hand, Dreadnought might have a little left. We're just going to have to watch and find out. They're both really smart pilots, so I think it's going to be really fun to watch. I can't believe I'm saying that.
A whole year of preparation finally comes down to just 8 laps around the course at Reno. All the tricks come out of the bag now, and the basic strategy is to go fast and don't brake. Under the direction of Bob Hover, the pilots carefully line up for the start of the race. And they're off. In first lap, Strega again takes the lead, followed by Dreadnought, RENO Air, and Stiletto. In the second lap, as around pylon 6, Dreadnought passes Strega and pulls ahead. It appears there's more power in that big round 4360 than Bricker has let on. And so it goes, lap after lap. Dreadnought dominates the race. But in the middle of lap 7, Tiger DeStefani in Strega makes his move and passes Dreadnought, pulling away. This seventh lap is timed by many at over 469 miles an hour. The concern I hope now is his bulletproof durability. But as he streaks through the final lap, Estefani proves that Strega is bulletproof too. The winning speed is over 452 miles an hour. This is the fastest race ever flown at Reno. Tiger DeStefani, pilot and owner of Strega from Bakersfield, California, has done it. And coming back down to earth, he knows he's won the gold in the fastest race on earth.
Oh, no. How'd we do better?
He was smoking. Yeah, I can't believe it. He hung in there and did it. Yeah, I think that both of us. He was 452. I think we were over 450. Yeah, that's what they were just. No, I think we're pretty proud of the performance of Dreadnought, and we're just dazzled by the performance of Strega. Now they want to know how that little mouse motor outrun that big ram. Oh boy, those elephants hate Mises to pieces. Tiger was right. He said the mouse motor would hang together. Strega did it. The race ends. Everybody's going home, and you can hear them all thinking to themselves, just wait till next year. We had a lot more.
Just like to say, can't wait till next year. Stay tuned for the bonus buyer's guide at the end of this tape. You know, many of the manufacturers using this video showcase have special pricing and information offers available to viewers of ABC's Wide World of Flying. Over the past few months, we've heard from many of you indicating that our editorial material is right on track. If you do across a story or a product that should be seen on ABC's Wide World of Flying, don't hesitate to drop us a line at either headquarters or editorial offices. And the addresses are on the back of the box cover. Also listed is a toll-free number and address for our subscription services department in Iowa. Use that for any change in your address. In video issue 4, we'll be taking you on a flight across the Atlantic in a single-engine Piper Malibu, giving you a checkout in a World War II Corsair, and much, much more. For many of you, this is your third paid issue in a subscription of 4 videotapes. Now that means it's time to renew. Extending your subscription now protects you from any future price increases and ensures you uninterrupted delivery of ABC's Wide World of Flying. To renew, simply fill out the renewal form and use the envelope provided. You'll find these attached to the package that contained your tape. Or call our toll-free subscription number. That's 1-800-999-783. Do it now to be assured the lowest annual price. Now stay with us for our bonus buyer's guide. And until our next quarterly video, safe flying.
Hello, fellow pilots. I'm John King of King Schools. I'm going to share a tip with you from our newest course, 101 Ways to be a Better, Safer Pilot. This tip just could help keep you from coming spinner to spinner with another airplane at an unfamiliar airport someday.
And I'm Martha King. I'm going to share from 101 ways that should help keep you safe and your engine healthy on descent to avoid a TCA.
The FAA encourages pilots to make traffic advisory position reports at uncontrolled airports, and nearly all of us do. But these reports don't do any good at all if they're made on the wrong frequency. Now, the FAA specifies a common traffic advisory frequency for each uncontrolled airport. Of course, you can look up the frequency in the airport facility directory or on an IFR chart. But if you don't have either of these handy, it would be helpful to know the method the FAA uses to designate the common traffic advisory frequency for an uncontrolled airport. Here's how to know what frequency to use. If the airport has a control tower and the control tower is not in operation, then you'd use the control tower frequency to make position reports. Now, if there's a flight service station on field, the flight service station will answer on the control tower frequency to tell you about any traffic they know of. Now, if there is no control tower at all on the field, but there still is a flight service station on field, you'd make your position reports on frequency 123.6. Now, if there's no control tower or flight service station on field, but there is a Unicom, use the Unicom frequency. And if there's no control tower, no flight service station, or Unicom, then you'd use the frequency 122.9. With this information, you'll have one more tool to avoid that spinner-to-spinner encounter at an unfamiliar airport someday.
In a busy terminal area, having a rule of thumb ready for planning descents in your airplane can prove to be very handy. Here's a case in point. Let's assume you're crossing the Julian Vortex at 10,500 feet and you're en route to Montgomery Field in San Diego, and you want to avoid the San Diego TCA. You'll be flying out the Julian 210-degree radial, and it's 25 nautical miles to the edge of the TCA. At this point, you must be below 4,800 feet, and you'd like to be at 4,500. Here's a quick rule of thumb you can use to tell when you need to start down. Let's assume you'll be doing 180 knots ground speed on your descent. That's covering 3 nautical miles per minute. If you use a 1,000 feet per minute descent with some power in to avoid shock cooling your engine, then you'll be covering 3 miles forward for every 1,000 feet of descent. That gives you a descent ratio of 3-to-1. To know when to start descent, just multiply the altitude to be lost in thousands by 3. In this case, you need to lose 6,000 feet. This means you must start down 18 nautical miles from the edge of the TCA, or 7 miles past Julian. You can use this same rule of thumb to check your progress during the descent and adjust your rate of descent if needed. Figuring the descent ratio for your airplane in advance will help keep you safe and your engine healthy the next time you need to avoid a busy TCA.
Whether you want to get up to date for a biennial flight review, pass a written test, or prepare for a check ride, it's all guaranteed. King Video Ground School trains you to understand the big picture by taking you on location in the cockpit, in the weather, or in the tower. Monster graphics make difficult problems fall into place with ease. Private Pilot magazine says the student who follows John King's lecture, graphics, and numerous sample problems will have an excellent understanding of the subject. Plane and Pilot News says our evaluation panel found the King Accelerated Ground School tapes, in their opinion, to be the best offered. Here's what students say.
This is Patty Wagstaff and her Pitts S1 Special.
I've taken 2 King Ground School courses. My sister's taken a couple, and my husband's taken probably 3 or 4. And every one of them has been really successful and really fantastic. And we've all done great on them, too. We've gotten really high scores. And can attribute it all to John and Martha, to King Accelerated Ground Schools.
Hi, my name is Rick Gillette. I used the King Home Video course to obtain a 96 on my instrument instructor written exam. Couldn't have done it without King.
I took the King Private Ground School course. I thought it was a very concise and thorough course, and it gave me everything I needed to pass the FAA written with a score of 88.
It raised my level of confidence quite a bit. I did get a 92 on my private test, and I got a 98 on my IFR test, and I feel really, really proud.
And I find that they're very easy to follow, and being able to rewind them and review makes it even more easy.
The newest King course, 101 Ways to Be a Better, Safer Pilot, is a course every pilot will benefit from. You'll learn rules of thumb, how to predict local weather conditions, how to avoid being deceived by optical illusions in flight, how to avoid mechanical problems in flight, how to communicate on the radio with ease, and much, much more. The special introductory price is just $99 for 4 hours of practical learning. King VFR and IFR Updater courses are a great way to prepare for a biennial flight review or just get current again. Each is $99 for 4 hours of informative video. King written exam courses include at least 5 2-hour videotapes, a course book, 3 practice exams with answers and detailed explanations, plus your exam sign-off. Exam courses for only $199 are instrument, commercial, flight instructor, instrument instructor, ATP, and flight engineer. The private course is only $149. King flight test courses show you how to ace your private, commercial, or IFR flight test. An actual FAA examiner tells what he expects of you, and your instructor shows you how to demonstrate your knowledge on the ground and in the air. Each course includes the Practical Test Standards booklet and 2 videotapes for only $89. For same-day shipping, call 800-854-1001. You'll have a 20-day free trial, and if you fail your test, you keep the course and get your money back. Order within 30 days and mention ABC's Wide World of Flying, and we'll give you a bonus for promptness. The King Takeoff Course Album, a $60 value. Your bonus includes audio cassettes on mountain flying, weather flying, flying the high-flying recips, and frightened spouses. To get your bonus for promptness and your King course, call 800-854-1001 now.
They say in the book, you should never rely 100% on one particular instrument. Although I think you could, because we've never had any failure. And they're right to say that, but the fact that it's so precise and so reliable, like I say, it makes you very comfortable.
We have 20,000 waypoints listing on that little machine. It's unbelievable. No? Plus, we have 200 waypoints we can put in our own waypoint on top of that. That's really something absolutely wonderful on that. And really, we feel very comfortable with that because we can go anywhere, even of a small air show. We know we're going to find the airport in a machine.
When we first looked for Lorraine, our prime thing was really something easy to use. And by looking through all the brochure and everything is on the market, the M1 came out as the easiest one to use. And after we had it installed on the aircraft, we found it was absolutely true. We did an air show a few weeks ago, and we were a bit anxious of keeping our bearings from the airport. So I kept my Lorraine on, and as we're doing lobes and hammerhead and barrel, after about 2-3 minutes, it came the warning light on. So I push it, and it says something like, "I'm sorry, I don't know where I am anymore." So I pushed it twice, and within about 10-15 seconds, it came back and gave me the bearing back to the airport.
It's safer and it's nice for us. Every time, every minute, you know where you are. I say that North Star is really the best way to use it. It's easy to use. It saves us a lot of time in a traveling. We don't follow the road anymore. We go point A to point B. And it seems like you have somebody talk to you inside the aircraft.
Airworkers and Pilots Association offers its members a wide range of benefits, from legislative representation to Pilot Magazine. But right now, we would like to focus on the services of the Flight Operations Department, which is just a phone call away for our members who are planning flights across the country or across international borders.
Okay, Halifax is an airport of entry, and let me give you the number for customs there. It's 902-426-1335. Here in Flight Operations, we try to help the general aviation pilot, whether they're going from coast to coast into Mexico, the Bahamas, the Caribbean, flying to Canada, or making a transatlantic flight or around the world. Out of these services, we try to help them figure out or what the documents they need for the aircraft in making these flights, if there's any special papers that they need on board for themselves. And a lot of these people, well, we also give them the services to contact people that maybe have made these flights, and we'll be able to provide them with better, more updated information and keep people in contact with each other. And we do have packets of information that we do send out to general aviation pilots so they can have material to study. We provide them custom services, the airports, the information on the airports, and we will give them the type of documentation that they may need to make the flights.
The instant assistance of AOPA's Flight Operations Department is just one of the many benefits enjoyed by members. If you are a pilot or aircraft owner, we invite you to join the organization now. If you would like to join the Aircraft Owners and Pilots Association and receive all the benefits of being a member, plus Pilot Magazine every month, simply call their toll-free number, 1-800-USA-AOPA. They will be pleased to answer any questions you may have and will take membership information right over the phone. If you are viewing a borrowed copy of Wide World of Flying and would enjoy having your own subscription, or would like to order a subscription as a very special gift for a pilot or aviation enthusiast, credit card holders may call us toll-free at 1-800-999-8783. Or you may send a personal check to our subscription center in Des Moines, Iowa. The price is just $99.95 for 1 full year.